All attendees are in listen-only mode.
Welcome to today's webinar, Protecting the Engine Behind Your Business. Let me start out by thanking you for your time today. We hope that you find the information that we are about to share beneficial for you and for your team. If you are looking at SolidWorks or currently using it, some recent media coverage on the kernel change may be giving you second thoughts. Hi, I'm Yvonne Wiedemann of CamLogic, and I'd like to spend the next hour showing you a way to protect your investment in 3D while getting a boost in productivity at the same time. First, I'd like to recognize Coach Yachts in France for supplying an image of one of their products, a luxury yacht. This design was completely modeled in SolidEdge. Let's start out by familiarizing ourselves with CamLogic. CamLogic has been in the CAD, CAM, CAE space for over 35 years. The company was established 16 years ago, initially focusing on CAM, servicing mainly the tool and die shops in the area. As the market has evolved, CamLogic has evolved. Interestingly, working our ways backwards from manufacturing back to the concept of the idea or to the design. Because we started towards the end of the process and worked our way to the beginning, CamLogic has the fundamental knowledge of what has to be done to assure that each step of the process will result in a product that will actually work or fit into the next phase of development. CamLogic has chosen to represent software and tools that enable our customers to fulfill the full cycle of product development. We consider ourselves integrators and partners for our customers instead of resellers. CamLogic employs the three-legged stool strategy. We partner with Siemens, offering the complete integrated Siemens portfolio for design, machining, analysis, and data storage and retrieval. We partner with 3D Systems for 3D printing and rapid prototyping, and Romer and Creoform for 3D scanning for inspection and quality. Now that you've heard a bit about CamLogic, let's start with the basics that are behind your design system and ultimately your business. The brains in any CAD system is the geometry kernel, which handles all 3D creation. Constraint solvers manage position between 2D or 3D elements, and the data platform defines how files are stored. These are complicated systems that are often licensed from experts in the industry. Geometry kernels are what's behind any and all 3D creation, from solid construction, surface design, computing mass and volume, checking part-to-part interferences, and advanced modeling operations such as blending or thin walling. Kernels are also responsible for creating 2D drawings. They use the 3D model to compute edges, such as visible, tangent, and even hidden lines within a part or across an assembly of components. A kernel is the component that creates drawings such as orthogonal views, detail section isometric views, and auxiliary views. Kernels also keep these views up to date when changes in the 3D are made. A little known fact is that kernels also handle display. They use a process called tessellation to break a 3D model surface into small triangles that are passed to the graphics card for data display processing. Kernels also generate geometry such as edges, faces, and bodies that are used in selections. Simply put, kernels are the brains of any CAD system. So, if a kernel is the brain, a solver is the heart. Constraint solvers manage and maintain the position of 2D elements and sketches that are used in layouts and 3D feature construction. They also manage the fit between components in an assembly. If you move one element and other parts keep tangent, aligned, or concentric, you can kindly thank the constraint solver for that. Once a part is designed, it must be saved. The most common storage system is file on disk. If you are using a PDM system, the storage location becomes a database. From concept to production, all these pieces must work together, and here's how. Users input parameters such as sketches, dimensional values, or element selections, and upon command execution, the kernel processes those inputs and creates the required geometry. Once created, the kernel displays that for viewing. Finally, any work is saved to disk in a language the system understands. Depending on the operation, this process is generally transparent to the user, all managed by the kernel and data platform. The capabilities available to use are dependent on the core components in defined systems. Command functionality, compute and update performance, modeling and drawing reliability, and how secure and accessible your data is. Although all CAD systems have these core tools, not all are the same. The kernels used by most CAD, CAM, and CAE applications is Parasolid, licensed from Siemens. SolidEdge and SolidWorks use this geometry kernel. Autodesk has their own kernel called Shape Manager. In this simple 4-edge blending example, notice the patch at the intersection. However, the Shape Manager result is different. Both are valid, but the point is different kernels give different results. In every copy of SolidEdge is Siemens technology. For 2D and 3D construction solving, 3D model creation and drawing support, and file storage that can be on disk or managed through SharePoint or Team Center. In every copy of SolidWorks is also Siemens technology for 2D and 3D constraint solving, 3D model creation, and drawing support and file storage that can be on disk or managed through SharePoint or Team Center. However, the announcements that you may have read about or heard about indicate that SolidWorks plans to swap out their core component for their own CGM platform, effectively changing the geometry kernel and how data is stored. Changing a kernel is a significant undertaking. This is just an example of a kernel function call to create an extrusion, but notice, function names are different, inputs are different, the order in which they are supplied are different, and some options may not be supported. Basically, a kernel change will require a rewrite of every operation, assuming you can find them in some 15 million lines of code. Let's just say you do get all function calls rewritten, different options accounted for. The question you ask yourself now is, are you safe? You know the results, performance, and capabilities with Parasolid. But what will happen after SolidWorks makes a change? Your models will get different results, but what will happen to tooling or the fit and position between close tolerance parts? Different results mean different design impact. A platform change may affect, can you design what you want? Can you design and refine fast? Will your drawings be right? Can you get to your data? Design is not guesswork. Different results means different impacts. A platform change may affect, will you be able to innovate? Will your customers suffer? Will you create excessive scrap? Will you have to hire IT staff? Hope is not a good business strategy. If you are concerned about SolidWorks plans on switching the kernel, you do have options. Introducing SolidEdge with Synchronous Technology, a way to design better, a way to get accelerated design, faster revisions, better imported reuse, and all with a fast adoption. Thanks to another SolidEdge customer, Starrett Corporation, for supplying this image of one of their products designed in SolidEdge. SolidEdge, while a complete 2D, 3D CAD solution, is different from other systems you may be familiar with. We offer Synchronous Technology for accelerated design, faster revisions, and better reuse of imported data, and many other areas like production, proven drafting, integrated analysis, and a full suite within the Velocity series to help you improve your complete manufacturing process. So, why is SolidEdge different, and how can it help you design better? Well, let's first review current CAD technology. As I've mentioned, there are history-based modeling tools. In history-based modeling, models are driven by dimension, use features like holes and blends that make modeling intuitive, and allow ways to build highly automated models so changes can ripple through the entire model and be updated in other key areas. To get this level of automation, operations must be captured in a specific order, meaning modeling steps must be carefully planned out. If steps are not planned well, making changes can often not be done. And since every edit regenerates all subsequent operations, changes tend to be slow. CAD systems such as SolidWorks and Inventor suffer from this methodology. On the other hand, less popular systems such as IronCAD and Creo Elements Direct use a history-free modeling approach to 3D design. This method is similar to 2D, where changes can be made directly to the model without the worry of the construction methods. Design creation using these systems tends to be fast because modeling steps don't need to be planned out and edits are flexible. But the downside is because there isn't a concept of features, changing basic parameters like patterns or holes tend to be a delete and recreate operation. And a lack of design automation makes controlled change nearly impossible to manage. Most people recognize the performance, but the inability to automate design makes them less popular for production work. Having identified the strengths and weaknesses of both models, we found a way to marry the strengths from both of these design methods. Taking the strengths from both models, we then create what we call the best of both worlds. Synchronous Technology combines the speed and flexibility of history-free CAD with the precision and automation of history-based 3D. You can create without pre-planning, using dimensions and features to develop highly automated designs while getting blazing fast performance during edits. Synchronous Technology combines the speed and flexibility of history-free CAD with the precision and automation of history-based 3D. You can create without pre-planning, using dimensions and features to develop highly automated designs while getting blazing fast performance during edits. So what advantage does Synchronous Technology bring to your designers? Well, a way for you to design better. Simply put, Synchronous Technology offers accelerated design, faster revisions, better reuse, and it's easier to learn. Let's take a closer look at how we can help you design products faster. With our unique way to design using both 2D and 3D, you get full digital prototyping capabilities. With automatic intent capture within Synchronous Technology, you can quickly redesign and refine on the fly. And the best part is our unique feature-based, history-free approach eliminates design pre-planning. If you're looking for accelerated design, how about doing it so you can get to market up to 25% faster? Let's take a look at how we can help you revise and refine your designs faster. Our unique live rules let you make designs that preserve intent without having to define it, and without rigid design and model constraints. You can make changes as you need, not how the model dictates. And the most valuable part is with Synchronous Technology, models don't regenerate, so you can expect blazing fast performance. What does this all mean to you and your customers? You can get design revisions in minutes instead of hours. Let's take a closer look at how we can help you reuse more imported 2D and 3D data. You can push, pull, and rotate geometry with the steering wheel, and some key features will be recognized, allowing parameter type modifications. You can also make precise changes by adding 3D driving dimensions directly to the completed or imported models. And my personal favorite is our unique live rules automatically finds designs intended from the 3D model, even the rules lost during translation. And what does that mean to your design team? You can make revisions in-house and eliminate change fees. All of these capabilities that benefit you and your business are easier to implement than you think. First, a direct interaction interface means less time learning commands and workflows. Since Synchronous Technology isn't history-based, you don't need to learn how to manipulate complicated CAD constraints. And if you are used to 2D, you can use the same simple commands but get the value of 3D. What does this mean to your business? Make all your users experts in less time. So what advantage does Synchronous Technology bring to your design process? It's a way for you to design better. Simply put, Synchronous Technology offers accelerated design for getting products developed up to 25% faster. Faster revisions that can speed customer turnarounds and virtually eliminate change fees. Help you better reuse 2D and 3D data for lower design costs that can be passed on to your customers, and an all-in system that is easier to learn so you can become expert in less time. So what advantage does Synchronous Technology bring to your business? It's a way for you to design better. Simply put, Synchronous Technology offers accelerated design for faster revenue recognition, faster revision for more repeat business, better use for more competitive pricing, and a system that's easier to learn for virtually eliminating manufacturing downtime. Helena, a medical device company, was one of the first companies to purchase SolidWorks. They were a long-time customer and doing fine, but very concerned with the kernel change. Billy Oliver, a design engineer at Helene Laboratories, wasn't willing to wait around, so they took an opportunity to look for ways to design better, and they found SolidEdge. They moved to SolidEdge and preserved 100% of their data. Now that's impressive. Caprock, a contract manufacturer, also had concerns about the kernel swap. Joshua Walls, a senior project engineer at Caprock Manufacturing, claims that while using SolidWorks, if you discover a mistake made earlier, in many cases, just forget it. You might as well start over. They moved to SolidEdge and were able to cut design time by 5 times over. Now let's take a break from my talking and see SolidEdge with Synchronous Technology in action. We'll see a few quick demos, starting with how to design without pre-planning, and then we'll see blazing fast revisions, followed with how you can edit imported data, concluding with how easy SolidEdge is to adopt. Now I'll hand this over to John.
SolidEdge ST3 has an integrated design environment that allows you to apply ordered features to synchronous models. Synchronous modeling provides a perfect foundation for accelerated design, faster edits, handling imported data, and allows ordered features for process-type parts. Synchronous modeling helps you create 3D parts quicker because design pre-planning is no longer needed. We'll begin this engine cover by drawing and dragging sketches into 3D features. Sketches can be created in 3D space or directly on the 3D model. When selected, most sketch regions display a handle, and a quick grab and go turns them into 3D features. Pulling regions adds geometry, and pushing them removes material. With fewer commands to learn, new users adopt SolidEdge faster, and experienced users design more efficiently. Working top-down, adjacent parts can be used as a guide, ensuring parts fit together as you design. Fast, flexible edits make designing in SolidEdge a fluid experience. Watch as we easily add height to the guard. Geometry creation and manipulation is simple. Select a 2D region or a 3D element and use the drag handles to edit the part to shape. Dimensions appear or can be added at any time for precise change. While Synchronous forms the design foundation, SolidEdge ST3 allows adding ordered features for process type steps such as castings with its machined counterpart or documenting the cutting steps after a weld operation. Here, we'll add a stylized shape to the top using SolidEdge's Rapid Blue Surface tools to increase the appeal of the final design. Adding traditional treatment features such as rounds and a thin wall are quick and simple. As you design, features are collected in the Pathfinder but are not dependent on the creation order. You can make edits to any feature, and unaffected operations are not regenerated. Imagine editing the first operation as fast as the last. Creating models with synchronous features and having the ability to add ordered steps greatly extends your capabilities. You have the speed and flexibility when making precise edits, and any ordered operations documenting a process are maintained. With an integrated design environment, SolidEdge ST3 fulfills the vision of synchronous technology for accelerated design, faster, more flexible change, and more reuse with imported data. If you've used a traditional 3D CAD system, you're familiar with performance issues due to model regenerations. Let's look at a typical engineering change order scenario and see how much faster edits can be made using SolidEdge with Synchronous Technology. Most change orders begin with documenting a set of requirements. View and Markup in SolidEdge allows you to efficiently mark up assemblies, parts, and drawings, which can be emailed using a lightweight PCF file. Recipients of the file can view the changes in Express Review, a free viewer that can be downloaded today. You can package all types of documents such as requirements documents, spreadsheets, drawings, and even images. After reviewing the requirements in this engineering change order, it's time to make the edits. Before we show you just how fast SolidEdge with Synchronous Technology is, let's refresh your memory on what it takes to make changes in a traditional 3D CAD system. We'll start with this console cutout. Feature edits in a traditional CAD entail a delete and recreate process, so during any edit, the model rolls back, deleting all subsequent features. Only features built to accommodate future changes will update correctly. We got lucky here as this feature was constrained to keep the cutout in the correct position. This simple edit took over 15 seconds to make, but larger models can take much longer. We'll make similar edits to the frame and hanger clearance pockets. Once the edit is complete, all remaining features must regenerate, even operations that were not affected by the change. This rebuild process is a common source for model failures because subtle changes can cause severe and unexpected results. The behavior of this 20-year-old architecture is what most people consider the norm. Let's now make a more complex edit to the tank profile. Since this change wasn't something the designer planned for, the results will be unpredictable. Once the edit is complete, notice how many features failed. The original designer didn't build the model in anticipation of such a change, and this is a classic problem found with traditional CAD technology. During the regeneration process, subsequent features are bound to break. Imagine the number of steps required to fix all these features. Creating models flexible to changes in a history-based system takes a tremendous amount of pre-planning during the construction phase so that edits will give the correct results. As we see here, the model wasn't built to accommodate even the simplest changes, and if you did not originally create the part, you have to untangle someone else's mess before you start. Let's now see how SolidEdge with Synchronous Technology eliminates these issues. We'll make the same changes in SolidEdge so comparisons between the technologies can be seen. An initial difference is how models are edited directly. With this approach, changes are made directly to the geometry, so you can edit in the most convenient way. Simply drag a face or add 3D driving dimensions. Remember, the edits with traditional CAD took a while to recalculate and lots of additional time was required to fix failed features. But using SolidEdge with Synchronous Technology, these edits are done in just a few seconds. The edits you see here are happening in real time. When you need to make fast, reliable changes, there really is no better system than SolidEdge with Synchronous Technology, even with parts coming from other systems. SolidEdge ST3 lets you preserve design intent from imported 2D drawings to imported 3D models to improve data reuse. Let's start the process by reading a 3D part and associated 2D drawing from another system. SolidEdge's migration wizard ensures drawings look the same in SolidEdge as they did in the original system, including layers, line styles, color drawing scales, and more. Using the Create 3D command in SolidEdge ST3, manufacturing dimensions from the 2D drawing are automatically added to the imported 3D model. These manufacturing dimensions are key when making changes. The goal of the designer is to alter the dimensions directly and not indirect sketch dimensions used during the modeling process. Prior to Synchronous Technology, imported models had to be redesigned to allow edits, but with these new enhancements, designers can make the changes as defined in the 2D drawing. Once the process is complete, the 3D driving dimensions can be edited. Unlike feature dimensions that control parts of the model, designers can now control what really matters, such as distance between holes and overall size across multiple features. The ability to edit imported models with precise dimensional control is made possible only with Synchronous Technology. During edits, design intent lost in translation is found and maintained with live rules. This keeps designers from having to remodel imported parts even when simple edits are needed. A similar behavior is seen when the base plate thickness is adjusted. Other coplanar faces are maintained, keeping the designer from making two edits. You can add dimensions from other drawing views all at once or at any time, depending on design needs. Here, the dimensions from an auxiliary view will be transferred to 3D, ensuring the positions of holes along the angled face are kept using the dimensions defined in 2D. Even intent established in detail views can be transferred into 3D. Regardless of drawing view scale, dimensions can be moved from 2D to 3D and are ready for edits. Watch as a precise change is made. Finally, fully associative SolidEdge drawings can be easily generated and manufacturing dimensions can be retrieved, ensuring design intent is maintained throughout. This new capability within SolidEdge ST3 helps designers reuse more 3D data from customers and suppliers, which help reduce overall engineering costs. Learning 3D isn't always as easy as you thought, and nothing like the familiar concepts you used in 2D. SolidEdge with Synchronous Technology provides an innovative new way of modeling that lets you realize the advantages of 3D without completely changing your machine design process. Let's see how fast models can be created. Starting in the assembly of this garden utility vehicle, we'll model a new part that connects the transmission to the chassis. The interface promotes fast adoption to modeling. Notice how the menu ribbon lists sketch commands along with 3D modeling tools, while handy command tips help you learn as you go, reducing training costs. We'll turn tips off for now, but we'll see more learning tools as we go. While we know the locations of the fixed components, we don't have a clear picture of how to connect the support to the transmission and chassis, so we'll figure that out as we go. The transmission is in a fixed location, so we'll start here by using a 2D sketch that contains the basic design for the support. It's not complete, but enough to get started. Hiding the assembly for now will let us focus on part creation. When drawing elements, you can use other parts as a guide, guaranteeing fit and position, but for now we'll just place the mounting lugs in a convenient location and position them later. During drawing, notice how SolidEdge has several drawing aids to help you create 2D sketches. For example, special icons display when certain key points are located, and alignment lines help you draw perfect horizontal and vertical lines. We'll mirror the sketches to repeat the detail. Closed sketches become regions and display a grab-and-go handle, so a quick pull creates 3D features. We'll add some depth to the center of the body to clear the auxiliary power takeoff pulley belt and create the transmission mounting lugs. Sketches can be drawn directly on geometry with a full complement of tools to control both position and shape. Creating cutouts or extrusions using a traditional CAD system would require different commands and design planning, but with SolidEdge we were able to develop this complete model with no 3D commands. As we grab the region, watch how material can be added or removed with a simple push or pull. We'll remove some material to form the auxiliary power takeoff tunnel. How do you find commands in a new system? Watch how the Command Finder provides a handy cross-reference guide to common commands, eliminating hunting. Simply key in a command you are familiar with and SolidEdge will find the equivalent or similar command in SolidEdge, showing you where to find it and even starting the command for you, rounding off the corners in this case. SolidEdge lets you refine your designs easily during the creation process. Here, we'll start by tapering the sides of the bridge and adjusting its size. Watch how the sides remain tangent as we drag the face. Likewise, we can move the top face and the model updates. This flexibility comes in handy when adapting components in a machine for other uses. Notice how the lug remains concentric to the holes as we drag it around. Because edits aren't dependent on creation order, the lug could just as easily drive the hole, so your designs can be easily modified to accommodate just about any shape. This is live rules in action. Relationships can be toggled on or off to get different results. Here, we try out the options by toggling the symmetric option. A traditional CAD system can't make these modifications without redefining feature constraints. Let's display the rest of the assembly and position the lugs to match the transmission and chassis. The hole in the transmission case and mounting hole in this lug are easily aligned. Live Rules ensures the opposite lug also moves to the correct location. Geometry can be moved with precision, either relative to its current position or parametrically with 3D driving dimensions. A unique capability with 3D driving dimensions is directional control, so edits can be made regardless of feature creation order. These dimensions can be locked and driven by formulas or spreadsheets. We'll finish up the design by verifying that the mounting holes are in the correct location. Working in 3D lets us see an adjustment is needed. Because SolidEdge is free from model history, the part can be quickly dragged into position, no feature dependencies to resolve. The flange ends are easily refined, and because of symmetry, Live Rules makes this edit a single operation. Notice as we make these changes that we're interacting directly with the geometry, never running special commands. The fewer commands, the more productive the process will be. A key point with this technology is that the system keeps the model intact throughout the process. The correct edges stay blended, mounting holes remain concentric, and orthogonal faces are maintained. SolidEdge with Synchronous Technology gives you the promise of 3D today.
So what is your next step? Don't take our word on what's going on. Get the real story from Dassault. Make sure you understand their short-term and long-term strategy. Talk to successful CGM users. These users will be the CATIA V6 users out there, but you need to hear it from them on how the kernel works. Start assessing your risks. What are the impacts to your design process, quality, time to market, and manufacturing? And please, take this opportunity to explore SolidEdge. Really, there couldn't be a better time to try the biggest breakthrough in mechanical CAD software, SolidEdge with Synchronous Technology. And it is currently at a buy one, get one price. When you buy one license of SolidEdge software and one maintenance pack, you will get one identical SolidEdge license free. This offer expires September 21st and is available only to companies with physical addresses in the USA. To get a free trial of SolidEdge, or if you'd like to schedule an on-site demo, please contact us as soon as possible. We are happy to get that started for you immediately. Please feel free to contact me with any questions about this presentation or any other items that we at CamLogic may be able to help you with. Again, my name is Yvonne Wiedemann. My contact is up on the screen for your convenience. You can call 248-969-9201 or email me at yvonnew@camlogic.com. I do want to sincerely thank you for your time today. I hope that we have been able to address some of the questions about kernels, kernel changes, and potential solutions with SolidEdge. Your time is valuable to me, and thank you again.